Hi everyone, I am Booma, Assistant Professor of Computer Science and Department, PSN College of Engineering and Technology. And in this session, we are going to see about the object-oriented analysis and design. What is meant by object? Object is a real world entity, and we are going to find some problem in the real world, and we are going to give a software or hardware solution for the particular problem. For that only we are going to analysis and design the object. So in this analysis and designing process, we are just analyzing what the object is used by the user. Object-oriented analysis and design is a software engineering methodology which is employed the object-oriented principles to design and analyze the complex problem in the real world. Okay, then it will be represents it using objects and their interactions, and then designing modulars and scalable solutions. It helps to create the software solution for the particular problem what we have find in the real world. And these are the some important aspects of object oriented analysis and design. First, the design patterns. Initially, we are going to design the patterns for the particular problem. So, design patterns are reusable solutions to common problems in software design. And next one is UML diagrams. UML diagram is a representation of solution for the problem. So, UML is nothing but a unified modeling language, a standard notation for creating a diagrammatical representation of the solution what you have find for the problems. Then use case. This is the most important thing in the object oriented analysis and design. Use case is nothing but it is done by the user. Use case is a interaction of the software system. So in object oriented analysis and design, use cases is to help the developers and stakeholders for understanding the requirements of the system and to design the software solutions properly. And the next is object oriented analysis. So in the object oriented analysis and design, we have to separate into two parts. First is analysis, and then only get the output from the analysis, and the model will be designed for the analysis output. So first, object oriented analysis. This is the first step of technical activity which is performed in a part of object oriented software engineering. So the first thing is the information domain is model. Initially we are going to find a problem, and then finding the domain which is the problem is comes under what domains, and the main particular things in the problem is characters, features, how interact the user with the systems. And next is behavior representation. It helps to understand what the characteristics of the object or solutions. If the characters jump when we use the button which is used to satisfy the features, then function described. Every program has a specific task or jobs it needs to do. So object oriented analysis helps to list out the jobs. And next one is data functional and behavioral models are divided to uncover greater details. Object oriented analysis is smart about breaking things into different parts. In the analysis part, we are going to develop the subsystem of the main problem, and then only we are going to develop the model for the modules. And starting simple, getting detailed. Initially we are going to divide the bigger problem into smaller parts and analyzing the each and every module of the problem, and then only started to getting into the solution find out. Then object oriented design. After the analyzing process, we are going to design the solution for the problem. In object oriented software development process, the analysis model which is initially formed through object oriented analysis, and then we are going to design for the analysis output. This solution is crucial because it shapes the analysis model into a detailed design model, essentially servicing as a blueprint for constructing the software. This analysis solution is being a blueprint to designing the solution in the object oriented analysis and design. And in designing, the first step is to subsystem partitioning. Partitioning is nothing but dividing the whole problem into a smaller subsystems. At a high level, major components of the system are organized into a subsystem. This practice is similar to creating modules at the system level, providing a structured or organized approach to managing the complexity of the problem. Whenever we are going to design a solution, before that we are going to analyze the problem. The whole problem is divided into smaller parts. Each and every part should be analyzed and getting output from the every individual modules, and then combinedly going to give a whole output. And next one, object encapsulation. A more granular form of modularity is achieved through encapsulation of data manipulation operations into object. So, for example, if a game has a character jumping, we put all the jumping stuffs neatly inside an object, which means we can use a single object for the similar operations. Is called object encapsulation. Then we are using the object reusability. We are enhancing the object of reusability. Then data organization of attributes. Object oriented design involves specifying how data attributes are organized within the object. The next, procedural description of the operations. Each and every operation should be described in a detailed manner. It requires a procedural description for each operations that an object can perform. We should describe the operations of each and every object in the designing process. Next, we are going to see the layered approach of object oriented design. We have 4 layers in the object oriented design. The first one is responsibilities design, next message design, then class and object design, final one is subsystem designing. So in this subsystem layer, the first layer is the subsystem layer. It represents the subsystem that enables software to achieve user requirements and implement technical framework that meet users' needs. So requirement gathering is the initial step whenever we are going to solve a problem. So in this subsystem layer, we are going to get the requirements from the user. And next one, class and object. In this layer, in the second layer of the layered approach, we are going to define the class and object which we are going to use in the designing of the solution. It represents the class hierarchies that enables the system to develop using generalization and specialization. Generalization and specialization nothing but it is used to arranging the order of the object or classes. And the third layer is message layer. This layer deals with the how object interact with each other. In this message layer, we are going to detailedly describe about the interaction of the object. Each and every object should have a interaction between them. So it includes message sent between objects or method calls or flow of control within the system. The final is responsibility layer. It focuses on the responsibilities of each and every object. Whenever we are describing or declaring an object in the program, it should have a individual responsibility. So that in this layer we have focus on the responsibilities of all objects. Okay, let's see about some real world examples of object oriented analysis and design. So why we are using OOAD? So enhancing the maintainability and promote code reusability. For that only we are using object oriented analysis and design. In this software field, we should know about the reusability of code. It is enhancing the processing speed and decreasing the timing of the software. That's why we are using object oriented analysis and design in the real world solutions. So see some examples of financial system. So for example, we are taking a financial system as an example. So here we are using banking software. in banking software, in left and right side of we have 10 use cases. Use case is nothing but it is done by the user, end user. Use case is a operation of the particular software or solution. Object-oriented analysis and design is often employed in banking system to model complex financial structures, transaction and customer interactions. The modular and scalable nature of the OED helps to design flexible and robust banking application for means. If in the previous years we are using only bank as a transaction intermediator. Now we are using ATM machine or ATM card for transferring the money. Nowadays we are using mobile for transferring money like a GPay, Phone Pay. That softwares are used to transferring the money. This is the real world application or real world solution for the particular problem, which is done by the object oriented analysis and design. Let us see another example for OAD. Here we are see about the healthcare system. So administrator, doctor, nurse and patients are the users of particular software or solution, and then in the oval shape we are having 6 use cases: manage room allocation, generate reports, manage doctor information, manage nurse information, manage appointments, manage patient information. These are some examples of use cases. We can add some other use cases into the system. And next, e-commerce. This is also an example of object-oriented analysis, analysis solution using OAD. And online shopping. Nowadays we are only using online shopping for purchasing anything else. So e-commerce system. Here we see the use case diagram for online shopping. We have 3 users here: customer, staff and admin, and then 7 use cases are here. Each and every use case is connected differently with the users. So the connection between the user and use case is called relationship between them. So every use cases is done by a different users. Okay, then see about the phases of object oriented analysis and design. Here we are following some phases for developing solutions like software engineering. So object oriented analysis and design is a methodology for analyzing, developing, designing of a software solution. The process is divided into several phases. For example, requirements, design, implementation, verification, maintenance are the important phases in the object oriented design. But we have 7 phases. In deeply we are discussing about the phases. We have 7 phases in OOED. First is requirement gathering. Whenever we are going to solve a solution, initially we are going to gather the requirements of the solution. So in this phase, documenting the requirements of the system from the stakeholders including users, customers and other relevant parties. Requirements are typically captured in a document called software requirements specifications. So SRS document is describing about our requirement for solve the problem. So second is analyzing. After gathering the requirements, just analyze the requirement what we are gathered from the users. So in this phase, we just identify the object, classes and the relationship between the object or classes. It will be the part of software system. So requirement gathering in the previous phases analyze to identify the key functionalities and constraints of the system, and in the third phase is designing. Actually, we are getting the information from the user and then analyze the use cases. In this third phase, we are going to design the model for the use case. This phase is focused on the translating the analyzing models into a design model. So analysis model gives some output. Based on that, we are following some blueprints to design a model. It includes defining the architecture of the system, designing the individual classes or relationship between the objects or classes will be defined in the designing phases. And the fourth phase is implementation. After the architecture is designed, after that we are going to develop the solution, develop the software solution by using some any other programming language like Java, C++, Python, or any other else. The implementation phase also involves testing, debugging. It ensures the software meets the specific requirements. If the software meets the specific requirements, it will be move on to the next phase, or else it will be analyzed again and going to specify the requirements. Then testing. The fifth phase is testing. The testing phase involves verifying the software functions correctly and meet the requirements specified in the SRS. Yes, actually we are already see about the SRS document. SRS document is nothing but it is the description about the requirements. So based on that we are going to test the software, what is given output from the implementation process. Then the next one is deployment. After testing, we are going to deploy the software solution into the society. The testing approved, it is deployed to the production environment. This may involve installing the software on users' computers, servers and other devices. Ensure that it operates correctly in the production environment. Based on the requirement, we are testing the software. And then deployment. Deployment is nothing but we are using the software for any other feedback. Then seventh phase is maintenance. This is the most important phase of software system, because we are going to find the bugs or any other new features adding by using this phase only. So maintenance involves the updating process of the software. So this phase is ongoing throughout the life cycle of the software. I already say about this life cycle of the software. So maintenance is the final phase. Again if you are going to add any features, we have to analyze the feature and then add into the architecture, then design, and next is testing. The maintenance will be the rotation process for enhancing the software system. So next one is UML. UML is nothing but Unified Modeling Language, which is used to implement the object-oriented solution. So what is UML? UML is Unified Modeling Language. Is a standard visual modeling language used to field of software engineering to provide a general purpose developmental institute way to visual the design of the system. And it portrays the behavior and structure of the software system. And why we need to use the UML for developing the solution for the object-oriented design. So complex application need collaboration and planning from multiple teams, and hence require a clear and concise way to communicate amongst them. So that's why we are using Unified Modeling Language to develop the solution. So here we have some diagrams in the UML part. So here we have two types of UML. It's a diagrammatical representation, which is going to provide a diagram of the solution. So diagram is split into two varieties: behavior diagram and structure diagram. So structure diagram is divided into seven varieties. So first one is class diagram. It represents the classes, attributes and relationship between the classes or attributes. And second one is object diagram. It's an instance at a specific point in time depicting object and their relationship. Package diagram. The third one is package. It provides a high level view of the system organization. Fourth one is component diagram. It focuses on the interaction and useful for the system architecture. Composite structure diagram, the fourth one, it represents internal structure of the class, including parts and connectors. Deployment diagram, it depicts the physical deployment of the components and nodes in the system. Then final one is profile diagram. Profile diagram are a part of the UML extension mechanism. It's allowing the tailoring UML to suit specific modeling needs or domain. Then behavior diagram. The second category of the UML diagram is behavior diagram. Here we have some behavior diagram. First one is use case diagram. It describes the functionality of the user's perspective and it shows the actors and use cases who are involved in the software system. Activity diagram models the flow of activities and actions within a system, including parallel and conditional behavior. State machine diagram, it represents the behavior of an object or system as a finite state machine with states and transition. It describes the states and transition which is comes under the software solutions. The next one is sequence diagram. It shows the interaction between object over time. It emphasizes the sequence of the messages. Then communication diagram. It emphasizes the relationship between the objects and how they collaborate to achieve a task. Then interaction overview diagram combines activity and sequence diagram to provide the overview of complex interactions. It provided by the interaction overview diagram. Then the final one is timing diagram. Focuses on the time constraints of interactions, including lifeline and events of the software system. These are all some diagrams of UML, and let's see some examples about diagrams. Here we take only one diagram for your reference. So use case diagram. It comes under behavior diagram. Use case diagram is a vital tool in the system design. It provides a visual representation of how user interact with the system. So it represents the user and use cases and how they work and how they interrelated to the one another. And it's some notations of use case diagrams. So it represents the interaction between actors and a system under consideration to accomplish specific goals. So here we have actor, use case and system boundary. Let's see about the use case diagram notation. Here we have three notations to draw the use case diagram. It enables the software developers and designers and other stakeholders to communicate and document system design, architecture and behavior in a consistent and understandable manner. We have three notations: actor, use case and system boundary. First one is actor. Actor is nothing but the end user. So when the end user is called as actor, it's actor or external entity that interact with the system. This can include users and other systems, and also the hardware devices are called actors. And the next one is use case. Use case is done by the users. What the work is done by the user is called use case. It represents the specific things your system can do. It's called use case. So it may be place order or track delivery or update production information, whatever it is. It represents the oval shape. And then system boundary. The boundary is nothing but the outline of the system, use case system, outline of the use case system. Here we have scope of design and focus on relevance. The scope of design is nothing but why we are using this use case in a particular problem is called scope of design. Then focus on relevance. The diagram can focus on the illustrating the essential functionality provided by the system without unnecessary details about external entity. Then see about the relationship in the use case diagrams. It plays the crucial role in the depicting and interacting between the actor and use cases. This relationship provides comprehensive view of the system functionality and various scenarios. The relationship nothing but communication between the user and use case is called relationship. We have lot of relationship. Now we see about association relationship. It represents the communication or interaction between actor and use cases. It is depicting by a line and connected the actor and use cases. So the association relationship is denoted by a single line. So see some example. This is an online banking system. Here we are having one actor, one use case, and the relationship between the actor and users. So the actor is customer, use case is transfer fund. The relationship between the actor and user is association relationship. So it is denoted by a straight line. A line connecting the customer and the use cases. It indicates customers' involvement to the fund transfer process. It represents the communication between these things. Then now we see about how to draw the use case diagram in unified modeling language. By using the unified modeling language, how to draw the use case diagram. It has some steps. Now one by one we can see the steps. Step 1 is identifying actors. So actor is nothing but the end user who are going to use the software solutions. So this can be user, they can be user or system or other external entity. So in the initial step we have to identify the actors, and the second step is identify the use cases. In the first step we are going to identify who are all going to use the software system. In the second step, how to use the software system, that are called use cases. The main functionalities or actions the system must perform. So what is the process going to done by the system is called use cases. Each use case should represent a specific piece of functionality. The third step is connect the actor and use case. In the first step we are going to find the actor and then we are going to find the use case. Now we are connecting the actor with the respective use cases. In the third step we are going to connect the actor with the respective use cases. This represents interaction between the actor and the system. In the fourth step, add system boundary. Also we see in the previous slides, system boundary is nothing but the scope of the system. The boundary is used to define the scope of the system and define relationship. You can indicate their relationship with the appropriate notation. Already we see about the association relationship. As per that, what are the relations we are going to use in this system, that should be defined in this fifth step. In the sixth step, review and refine. This is the process of testing the solution. So ensure that it accurately presents the interaction and relationship in the system. This is review process. In the refining process, the unwanted relationship or use cases will be avoided in the refining process. The final step is validating. Use case diagram with stakeholders and gather feedbacks. The system is shared with the stakeholders and getting feedback from the stakeholder, and then it aligned with their understanding of the system functionality. Depends upon that we can enhance the performance of the system. So this is why we are using to develop the UML diagrams. So let's see some example of use case diagram. These are all the main parts of use case diagram. Here we are taking an online shopping system as an example. Actors are in the first step we are going to find the actors. So here customer and the admin, both they are the main actors of the system. And then use case, browse products, add to cart, checkout, manage inventory. in the admin side. These are all the main use cases of the online shopping system, and then relationship between the use case and actor. The customer can browse product, add to the cart, and then complete the checkout, and in the admin side, admin can manage the inventory process. So this is the diagrammatical representation of online shopping. Here we have 4 use cases: view items, make purchase, checkout, claim, register. Then we have 7 users such as actors, registered customers, web customer, new customer. Registered customer and new customer, there comes under web customer. Then authentication, identity providers, credit payment services, then payment process. These are all the actors and use cases of the online shopping system. The straight line mentioned the relationship between the actors and use cases. The use case is done by the user which is connected with the use cases. And these are all the some tools for you, tools to implement the use case diagram: Lucy chart, draw input output, Microsoft Visio, Smart Draw, Plant UML. These are all the important tools to develop the use case diagrams. So some benefits and purpose what we are going to use in the use case diagram: visualization of the system functionality, communication, requirement analysis, focus on users goals, system design, testing and validation. These are all the important benefits of using the use case diagrams. Thank you so much.